previous session, we have discussed about memory management, which is Java Heap and GC policies. So we have understood how Java Heap and it is divided into multiple segments and how the heap memory or the space from the Java heap is allocated and for which type of request or threads the heap space is allocated on what levels. And we have also understood what is an unreachable object and what is a garbage collection and how it works. Right. So young generation, old generation, meta space, and how GC work generalized. It is not categorized or it is not a type of GC policy, but generic GC policy, how it works, how it creates the objects, and when the GC will be triggered, and the example points of GC trigger, GC algorithms treatment of unreachable objects. So which type of GC is useful for various scenarios or various types of performance related issues, and the compatibility of each GC policy based on version JDK 8, JDK 11, 14, and 17. So the GC in each and every JDK version, along with the GC, there are many things that will be optimized in terms of performance, in terms of enhancements, and deprecations, removals of some features or options. So these all things happen in each and every new version of JDK. It is not about only the JDK, but also whatever the software you take it, uh, in each and every update or the new version of it, there will be improvements, fixes, bug fixes, and enhancements, deprecations, removals, and performance optimizations, security, hardening. So all these will be the part of new versions. So we have discussed the GC policies and different JDK versions. Each GC policy supports. Now, let us discuss in detail about each GC policy, and we will deep dive into the parameters, understand each GC, how it works, what are the parameters, what is the use case where we can use, and how the GC works internally. All right. The sequence and what are the limitations, when to use the GC. We are talking about each type of GC. So here it is parallel GC. We'll see how it works, what are the parameters, and what are the you know uh, adaptive parameters that contributes in improving and fine tuning the performance by cleaning up the garbage which are unreachable objects. So how the internal threads, the GC threads work, and yeah, so brief notes and how it internally works. Then the third one, concurrent mark and sweep, and which versions it is compatible and deprecated, what are the parameters, and different parameters to fine tune the heap memory and garbage collection. We'll understand the workflow, when to use the GC, CMS, concurrent mark and sweep, and what are the trade-offs. Number 4, G1 GC, which is highly optimized. It is a default in JDK 11 version. We'll see how it works. What are the uh, performance tuning parameters we can use to fine tune memory, right? The Java heap, and based on a few thresholds. You know, there are some scenarios like, we'll understand like STW, which is a stop the world case. So whenever the GC runs in the background, the application, there will be a pause time called application pause time. In this pause time, the application stops working, and that event is called stop the world. So yes, in order to handle this stop the world events, so what happens in the background when this event is triggered? Stop the world. The application pauses, and when the GC is happening or the cleanup is happening in the background in the heap memory, the application will not respond for some time. So that time has to be reduced, has to be very less, and that time is considered as the throughput, GC throughput. So there are different throughputs, and when it comes to GC, the GC throughput has to be optimized. In order to optimize it, we need to fine tune the memory and when to trigger minor GC, major GC, and full GC, and how to clean the objects, in which part, in which approach, segment by segment, or region by region, or memory chunk. And if you want to do a compact or fragmentation of the memory, so there are multiple things to be considered. So yeah, we are going to learn all these with the different and multiple scenarios uh, combined with various parameters to fine tune the memory, which is Java heap performance optimization. So here ZGC and the compatible versions, how it works, what are the parameters to be used. Um, yeah, so we will understand the memory resizing and what happens if you give XMS and XMX both same, and why when should you give XMS and XMX both as same value, and when you shouldn't be giving the same value. So what happens in both the scenarios, we will see that, and how ZGC works, and we'll have a comparison between different GCs, when to use each GC, and what are the GC tuning parameters, memory management enhancements, and what are the experimental features, and how, if you are seeing frequent out of memory errors, so what are the parameters you can use to collect the heap and GC, heap dump and GC logs for analysis. And these are the recommended for each, for each JDK version, and for JDK 8, which one is better, for JDK 11, JDK 17, and what are the troubleshooting and monitoring steps we can take in order to fix the memory related issues. So what may be the root causes? Too small heap, memory leaks, excessive session data, GC pause, full GC triggered. So we'll see the common issues and how to fix those issues. And there can, as we know, the Java heap, there are two things, heap and non-heap. So how to fine tune the non-heap, we'll see that one also. And what is the use of metaspace, and how to configure on WebLogic, where exactly do you configure uh, the GC logs, and if there are multiple servers in your domain, so where exactly do you configure, collect the necessary data to manage and to collect the data uh, for analysis. So it is going to be a deep dive. And yeah, so we look forward to understand each and every concept with a full coverage so that we can learn advanced memory management and also the thread management uh, to improve effective ways and effective methods to optimize the performance of the server, which impacts the business critical applications. So let us start from the basic one, the first one, which is